The universe is full of planets that make Earth look like a luxury resort, from surfaces hot enough to melt metal, to worlds where it literally rains rocks, to planets being devoured alive by their own stars. Today, I'm breaking down the most terrifying planets ever discovered, and the first one is closer to home than you'd think: Venus. Venus is almost the exact same size as Earth, same mass, same rocky composition, same general neighborhood in the solar system. Scientists literally called it Earth's twin. And that name is the cruelest joke in astronomy, because the surface of Venus sits at 462 degrees Celsius. That's 863 Fahrenheit, hot enough to melt lead. And here's the thing, that temperature never changes. Day, night, equator, poles, it doesn't matter. The entire planet is a uniform oven with zero escape. The atmosphere is 96.5% carbon dioxide, and the surface pressure is 93 times what you feel standing on Earth right now. Standing on Venus would feel like being 900 meters underwater, while simultaneously being slow roasted alive. You wouldn't just die, you'd be crushed and cooked at the same time. The Soviet Union actually sent probes there. The Venera missions are the only machines humanity has ever successfully landed on Venus, and the planet destroyed them in about 2 hours. These were spacecraft specifically engineered to survive the conditions, reinforced and pressure hardened, and Venus just digested them like they were nothing. But here's where it gets really insulting. Venus isn't even the closest planet to the Sun. Mercury is. Venus is farther away, and yet it's the hottest planet in the entire solar system. The reason is a runaway greenhouse effect so extreme that it trapped every bit of heat the planet ever received and never let go. Mercury has no atmosphere to hold heat in. Venus has a suffocating blanket of CO2 that turned the whole world into a pressure cooker permanently. Some scientists believe Venus may have actually been habitable billions of years ago. Oceans, moderate temperatures, the whole deal, which means this planet might have looked like Earth once, and then it died. Now here's what I need you to understand. Venus is the least terrifying planet on this list. It's the entry-level nightmare, because the planets we're about to cover make Venus look like a vacation. TRAPPIST 1b. Remember when NASA held that massive press conference back in 2017? 7 Earth-sized planets orbiting a single star, 3 of them sitting in the habitable zone. The internet lost its mind. Artists created gorgeous renderings of ocean worlds and alien sunsets. Headlines screamed that we'd found humanity's best shot at a second home. TRAPPIST-1 wasn't just a discovery, it was a cultural moment. People genuinely believed we were staring at the next Earth. TRAPPIST-1b is the innermost planet of that system, the closest one to the star. And when the James Webb Space Telescope finally turned its instruments on this world and measured it directly, the dream started to crack. Here's what we know. TRAPPIST-1b has a radius of about 1.116 times Earth's. Its mass is roughly 1.374 times Earth's. On paper, this thing looks like our planet's slightly bigger cousin, the kind of world you'd point to and say, that's the one. That's where we'd go. But TRAPPIST-1b receives more than 4 times the stellar radiation that Earth does. And the JWST data came back with a brightness temperature of approximately 508 Kelvin, which is around 235 degrees Celsius or 455 degrees Fahrenheit. Now, that number alone isn't the most extreme on this list, not even close. But the context is what makes it genuinely unsettling. The JWST measurement suggests that TRAPPIST-1b likely has no substantial atmosphere. None. No thick blanket of gas to redistribute heat from the day side to the night side. No weather systems, no wind patterns carrying energy around the globe. The side facing the star just absorbs everything and bakes. There's nowhere for that energy to go. An Earth-sized world sitting right there, completely bare and scorched. And that's the real horror of TRAPPIST-1b. It's not the temperature, it's a disappointment. This was the system people pinned their hopes on, the one that made space feel close for the first time in decades. JWST's data on the innermost world has quietly deflated a lot of that early optimism. The surface conditions are still model dependent, and scientists are careful to note we don't have a complete picture yet. But the implication is clear. The planet that looked most like us might be nothing more than a dead, airless rock getting cooked by its star. And that's just the first crack. And because the planets further out on this list make TRAPPIST-1b look like a mild sunburn. GJ12714b. For years, this planet had one of the coolest nicknames in astronomy, the Water World. A mini Neptune about 2.6 times Earth's radius and roughly 7 times its mass. sitting close enough to its star to complete an orbit every 1.58 days. Popular coverage painted this picture of a deep alien ocean, maybe something out of a science fiction film. An entire planet submerged in water. That image is almost certainly wrong. Here's the thing about GJ1214b. Scientists have been trying to read this planet's atmosphere for over a decade, and it has refused to cooperate every single time. Ground-based telescopes couldn't penetrate it, Hubble couldn't penetrate it. The atmosphere appeared completely flat, featureless, like staring at a locked door with no keyhole. Something thick was wrapped around this planet, and nobody could figure out what. Then JWST pointed its MIRI instrument at it and measured a dayside brightness temperature of 553 Kelvin, plus or minus just 5 degrees. That's an incredibly tight measurement, and it immediately ruled out a bunch of simple atmospheric models. This planet is hot, dense, and insulated by something capable of trapping enormous amounts of heat, but it's not water. Not in any way you'd recognize. Current interpretations point toward a cloudy, metal-rich, high mean molecular weight atmosphere. Think less tropical ocean and more high-pressure steam nightmare. A thick, opaque envelope of superheated vapor and aerosols so dense that light simply cannot pass through it. No surface features visible. No atmospheric layers to study. Just a smooth, blank sphere that tells you absolutely nothing. And it might be dying while it hides. A tentative detection of helium absorption, roughly 2.10% excess, with a margin of about 0.45%, suggests GJ1214b could be actively bleeding its atmosphere into space. Estimated mass loss rates fall somewhere between 1.5 and 18 billion grams per second. Those numbers are model dependent, so treat them as estimates, but the implication's wild. This planet is potentially evaporating in real time, and we still can't see what's underneath. That's what makes GJ1214b so unsettling. It's not violent, it's not on fire. It's not being ripped apart by tidal forces. It's just sealed. Completely, perfectly sealed behind opaque clouds that have deflected every instrument humanity has pointed at it. We've stared at this planet for years and it won't show us what's inside. But at least GJ1214b keeps its secrets quietly. The next planet on this list doesn't hide anything because everything horrifying about it is happening right on the surface. Gliese 367b. Everything we've looked at so far has been hostile. Extreme heat, crushing atmospheres, radiation that would cook you alive. But they were still recognizable as planets. Gliese 367b is where that stops. This thing was discovered by the TESS Space Telescope in December 2021, and the numbers that came back were immediately wrong. Not wrong as in incorrect. Wrong as in they shouldn't be possible for something this small. Gliese 367b is smaller than Earth, significantly smaller. We're talking 0.699 Earth radii and only 0.633 Earth masses. On paper, you'd expect something like a rocky little world, maybe similar to Mars. But then you look at its density, 10.2 grams per cubic centimeter. Earth's average density is about 5.5. This planet is nearly twice as dense as our entire world while being physically smaller. That number alone tells you something has gone catastrophically wrong with this planet's history. And the orbit confirms it. Gliese 367b completes a full year in approximately 7.73 hours. Not days, hours. You could sleep through multiple years on this planet. It sits just 0.00709 astronomical units from its host star, which is so close that the concept of orbit almost feels generous. At that distance, it receives roughly 500 times the stellar radiation Earth gets from the Sun. 500 times. The result is a dayside temperature estimated between 1,300 and 1,500 degrees Celsius. That's hot enough to melt most metals, hot enough to keep the surface in a partially or fully molten state, and critically hot enough to strip away any volatile compounds, any atmosphere, any water, anything light that might have once existed on this world. It's all gone, blasted away over millions of years of relentless irradiation. So what's left? Here's where it gets weird. The leading theory is that Gliese 367b is essentially an exposed planetary core. That extraordinary density, nearly double Earth's, is consistent with a composition dominated by iron. The idea is that this world once had outer layers, a mantle, maybe even a crust, and all of it was stripped away. What we're detecting now isn't really a planet anymore. It's the naked iron heart of something that used to be one. Now, to be fair, that interpretation is model dependent. The density and orbital data are rock solid, but the exposed core framing involves composition inferences that scientists are still refining. What nobody disputes is that this object is extraordinarily dense, unimaginably close to its star, and fundamentally unlike anything in our solar system. Gliese 367b isn't just a planet with bad weather. It might be the corpse of a planet that had its identity burned away. But if a stripped iron core sounds alien, wait until you see what happens when a planet is so hot that rock itself becomes weather. K2-141b. Up until now, every planet on this list has been hostile. But K2-141b isn't just hostile. It's two completely different nightmares stitched together at the equator. Discovered by the Kepler K2 mission in 2018, this planet orbited its star in just 6.73 hours. That's even faster than Gliese 367b. It sits 0.00716 astronomical units from its star, which is so close that the number almost looks like a rounding error. It has a mass of about 5.08 Earths and a density of 8.2 grams per cubic centimeter, making it a dense, heavy, rocky world. But the density isn't what makes K2-141b terrifying. The temperature is. The day side of this planet reaches approximately 3,270 Kelvin. That's roughly 3,000 degrees Celsius. At that temperature, rock doesn't just melt, it vaporizes. The surface on the star-facing side isn't solid and it isn't liquid. It's a churning ocean of molten and vaporized rock, with mineral vapor rising off the surface like steam off boiling water. Except the water is liquefied stone and the steam is rock gas. Now flip the planet around. The night side sits at approximately 73 Kelvin. That's negative 200 degrees Celsius, colder than any natural surface in our solar system, colder than the surface of Pluto. The temperature difference between one hemisphere and the other is over 3,000 degrees. Here's why that contrast is permanent. K2-141b is almost certainly tidally locked, meaning one face always points toward its star and one face always points away. There's no rotation to spread the heat around. No sunrise, no sunset. Just an eternal boundary between a vaporization zone and a deep freeze that never ever shifts. And this is where it gets genuinely cinematic. The leading model suggests that the vaporized rock minerals on the day side rise into a thin rock vapor atmosphere, get carried by extreme winds toward the night side, and then condense in the freezing cold. They fall back to the surface as a solid mineral rain, literal rock rain. Imagine standing at the boundary between hemispheres. Behind you, an ocean of glowing magma so hot the ground itself is becoming gas. In front of you, a frozen wasteland where vaporized stone is falling out of the sky as solid chunks. Two worlds, one planet. Now, the precise behavior of that rock vapor atmosphere and condensation cycle is still partly model dependent. Scientists are working with temperature analyses and atmospheric simulations, not direct observation of falling rock. But the day-night temperature contrast itself is supported by observational estimates. The extremes are real. The rain is the logical consequence. K2-141b is the point on this list where inhospitable stops being the right word. This isn't a planet that would kill you. It's a planet that exists in two states of destruction simultaneously, and neither one has any use for anything alive. But at least K2-141b keeps its horrors on the surface. The next planet has something far stranger happening underneath. 55 Cancri e. Most of the planets on this list are terrifying because of what we know about them. 55 Cancri e is terrifying because of what we don't, and not because we haven't looked. We've been staring at this thing with the most powerful instruments humanity has ever built, and the data keeps contradicting itself. Here's what we know for sure. 55 Cancri e is a super Earth, roughly 8 times the mass of our planet and nearly twice the radius. It orbits its star every 17.7 hours at a distance of just 0.01544 astronomical units. For reference, Mercury would look like a distant suburb compared to this thing's orbit. It's blisteringly close, unimaginably hot, and one of the most studied exoplanets in history. And that's exactly where the problems start. When Spitzer measured the planet's brightness temperature, it came back at approximately 2,360 Kelvin. Okay, fine. Scorching hot super Earth makes sense. But then JWST pointed its instruments at the same planet and returned different numbers. Phase curve analyses suggest a dayside temperature around 2,300 Kelvin, but with peaks approaching 2,700 Kelvin. Other published interpretations have cited still different values. These aren't minor disagreements. These are fundamentally different pictures of what the planet's surface is actually doing, and nobody can fully explain why. The leading models suggest a persistent global magma ocean, with inferred mantle temperatures reaching around 4,090 Kelvin, though that number is model dependent. Some researchers argue the atmosphere is made of rock vapor, literally vaporized minerals suspended above a molten surface. Others say the data points toward a CO2 or CO-rich atmosphere instead. Some think it could be a combination. The honest answer is that we don't have consensus. You might remember this planet by another name, the Diamond Planet. That headline came from early interpretations suggesting a high carbon to oxygen ratio, which theoretically could produce a carbon-rich interior with diamond layers. It was everywhere. Every science outlet ran with it. But those interpretations have been largely revised as more data came in. The Diamond Planet narrative still circulates widely online, which is a perfect example of how far popular science can drift from the actual research happening in real time. Here's what makes 55 Cancri E genuinely unsettling. This isn't a case of we found a weird planet and moved on. This planet has been observed repeatedly across multiple telescopes over the course of years, and every new data set seems to raise more questions than it answers. The temperatures don't agree, the atmospheric composition is debated, the surface conditions are inferred from models that produce different results depending on the assumptions you feed them. It's a world that is actively resisting our understanding, not because it's far away or hard to observe, but because the reality of what's happening there seems to be more complex than our current science can cleanly resolve. That's a different kind of scary, not the horror of knowing something terrible, the horror of looking directly at something and still not being able to tell what it is. But at least 55 Cancri E is confusing us from 40 light years away. The next planet on this list is being physically destroyed while we watch, WASP-12b. Most planets on this list are terrifying because of what they are. WASP-12b is terrifying because of what's happening to it. Right now, as you're watching this planet is being eaten alive by its own star, and we have the telescope data to prove it. WASP-12b is a hot Jupiter, roughly 1.47 times the mass of Jupiter, orbiting its host, a star, at a distance of just 0.0234 astronomical units. To put that in perspective, Mercury orbits our Sun at about 0.39 astronomical units. This planet is more than 16 times closer to its star than Mercury is to ours, and it completes a full orbit every 1.09 days. That's not a year. That's barely more than a single Earth day. At that distance, the equilibrium temperature hits at around 2,855 degrees Celsius. But the heat isn't even the worst part. The star's gravity is so intense at that range that it's physically pulling the planet apart. The WASP-12b isn't spherical. It's been tidally stretched into an egg shape, not metaphorically, not artistically, measurably. Observations have confirmed the distortion. This is a gas giant bigger than Jupiter, and it's being warped like putty by gravitational forces it cannot escape. And here's where it gets genuinely tragic. Hubble Space Telescope observations have directly detected atmospheric escape. The signatures of planetary material being ripped away from WASP-12b and funneled toward the star. Gas elements, entire layers of atmosphere, just streaming off the planet in real time. The planet's radius is bloated to roughly 1.9 times that of Jupiter, which is enormous, and that inflation is partly because the planet is literally being pulled apart at the seams. Mass loss models estimate that WASP-12b is shedding roughly 1 Earth mass of material every 30,000 years. Now, 30,000 years sounds like a long time. It's not. In astronomical terms, that's a blink. For context, the universe is 13.8 billion years old. A planet hemorrhaging that much mass at that rate is on a countdown, and the clock is already running. But what makes this even more unsettling is what Hubble found inside that escaping atmosphere. Water. HST observations detected water signatures in the atmosphere alongside the escape data. There's also been a broader scientific debate about the planet's carbon to oxygen ratio and whether methane has been detected in its atmosphere. Those claims have been contested and argued over for years, which tells you something important about this world. Its composition is so chaotic, so scrambled by the extreme conditions, that scientists can't even agree on what it's made of anymore. The planet is being disassembled faster than we can catalog its parts. Think about the scale of what's happening here. This is a world bigger than Jupiter, massive, ancient. A gas giant that probably existed for billions of years, and now it's being reduced to nothing more than fuel for its star. Not in some distant theoretical future, right now. Every observation we take shows more material gone, more atmosphere stripped, more of the planet fed into the stellar furnace it orbits. ASP-12b isn't a planet that might be destroyed someday. It's a planet that is being destroyed, visibly, measurably, irreversibly. Every orbit brings it closer to the end. Every pass strips more away. and there is nothing, no force in physics, that will stop it. It's a spectacle of destruction on a scale that's hard to even process. But at least WASP-12b has the mercy of a slow death. The next planet on this list exists in conditions so extreme that even its atoms can't hold themselves together. KELT-9b. Every planet on this list has tried to kill you in a different way. Crushing pressure, molten rock, acid rain, tidal destruction. But KELT-9b doesn't try to kill you. It doesn't even give you the chance to exist as a solid object. This is the hottest known exoplanet ever discovered, and it breaks the definition of what a planet is allowed to be. KELT-9b sits roughly 670 light-years away, detected by the Kilodegree Extremely Little Telescope Transit Survey. And what that survey found made astronomers question their own data. This planet orbits its host star every 1.48 days at a distance of about 0.035 astronomical units. To put that in perspective, Mercury orbits our Sun at 0.39 astronomical units. KELT-9b's orbit is roughly 10 times smaller than that. It's practically skimming the surface of its star. And the temperatures reflect that. The dayside brightness temperature approaches 4,600 Kelvin. That number alone is staggering, but here's the part that genuinely breaks your brain. The night side, the cool side, the side facing away from the star, measures approximately 3,040 Kelvin. Our Sun's photosphere sits at 5,778 Kelvin. That means the coldest part of KELT-9b is approaching the surface temperature of our own star. And the day side, it blows past it. This planet's hot side is hotter than the surface of the Sun. Not figuratively, not as a metaphor. By direct brightness temperature comparison, KELT-9b's dayside outperforms the star. But temperature is only half the story. Here's where it gets truly alien. At 4,600 Kelvin, molecules cannot survive. They don't melt, they don't boil, they get ripped apart at the atomic level. Spectroscopic observations have directly detected neutral oxygen, iron, ionized iron, and ionized titanium in KELT-9b's atmosphere, not as compounds, not as molecules, as free atoms and ions, shredded by raw thermal energy. This planet's atmosphere isn't gas. It's not vapor. It's a diffuse cloud of dissociated, vaporized metals drifting around a world that has more in common with a stellar surface than anything we'd call a planet. And it's disappearing. Carmene's instrument observations detected hydrogen alpha absorption signatures indicating a massive extended hydrogen envelope actively being stripped away from the planet. The estimated hydrogen loss rate exceeds 10 to the 12th to 10 to the 13th grams per second. Every single second, KELT-9b loses more mass than some comets weigh entirely. Remember WASP-12b losing roughly 1 Earth mass every 30,000 years? KELT-9b makes that look stable. This planet is evaporating in real time, bleeding itself into space at a rate that's almost difficult to comprehend. And the upper atmosphere is even worse. Thermospheric models infer peak temperatures potentially reaching 10,000 to 13,000 Kelvin in the outermost layers. Those numbers are model dependent, but if they're even close to accurate, the outer atmosphere of KELT-9b is hotter than the interior of some low-mass stars, not the surface. The interior. At what point does a planet stop being a planet? That's the question KELT-9b forces you to answer. It has the mass and orbit of a planet. It formed like a planet, but its atmosphere is made of atomized metals, its surface temperature exceeds stellar photospheres, and it's actively losing itself to space fast enough that it may not exist in its current form on astronomical timescales. KELT-9b doesn't push the boundary between planet and star, it erases it. And that's the scale of what this list has traveled. We started with Venus, a planet in our own solar system that kills you in under 2 hours with pressure and acid. We ended here, 670 light years away, standing on a world where the atmosphere itself has been ripped apart atom by atom, where iron floats as ions in a sky hotter than the sun, and where the entire planet is slowly evaporating into nothing. The universe isn't just hostile, it's creative about it. If you enjoyed this video and want to see more, click the video on the screen now,